This is the third session of the Code Then series on programming. I am Robert, and today we are going to be taking a look at operators. What's an operator? When you have a symbol between two numbers, we have the plus symbol between 2 and 3. We know that we are going to increase the value of 2 by 3, and hence we say we are doing addition. Well, to be a different story if we had the subtraction symbol in the middle of those two numbers. So an operator in mathematics is a character that is used to determine any action that would want to be performed or considered. Or you can have a look at other definitions, but in programming, it's basically the same concept. All right, let's proceed. Now we're going to talk about a particular operator which is known in the programming world as the assignment operator, but when it comes to the world of mathematics, we all call it the equal to sign. Now, when we say x is equal to 2, what we think of is anywhere we see x, we put there the value 2. In programming, we think of it differently. Anytime we see the equal to sign, we think of the straw and the soup, or you can think of straw and your favorite drink. When I say the straw, those who don't know what a straw is, this is a straw. Straw is that long tube that we put inside our soup or we put inside a drink. Okay, I think I'm right to call it a drink. You can call it wine. And then we suck, and you see the drink will just be moving up the tube right into your mouth. That's basically the straw. In programming, the assignment operator does exactly that. When you want to transfer an item on the right to a container in your left on your left hand side, you use the straw and then you suck it right into the left container. Now let's take a look at how it is done. So you see how it is. It looks like the straw. Put it inside a drink and then we suck the item on the right to the left. So which items would be on the right and what would be on the left? In programming, when we use the assignment operator, we have the left-hand side of the assignment operator and we have the right-hand side of the assignment operator. What you are sucking will be in the right or will be on the right, and what you are putting in, the receiving container will be on the left-hand side. So the assignment, an assignment in programming has two parts. We have the LHS and the right-hand side, right? So the container will be on the left because that's what you are trying to scoop, like absorb an item inside. And then on the right, we have an expression. So your soup, or you have powder, anything. So let's take a look at it this way in terms of programming. Enough of the scenarios. We have a container, and then the container is getting assigned a value in an expression. So we will pull in an item. When we talk about an expression in programming, all that we mean is you have a symbol, and the symbol is standing with either a number or another symbol together with some numbers or variables. Okay, we've talked about variables, and so we know what we keep inside variables. All right, so if you have 2 plus 4 and you are giving this value to a number, say x, you are basically doing the assignment operation. But this time, you are giving the result of an expression to the container on the left. If you have a number 5 and you are saying x is equal to 5, what you are doing is, in memory, you are creating a container called x, and you are giving it the value 5. That's basically the assignment operator. You can have two containers and say, oh, container B should be having the value of container A, which means in memory, any item the container A is having, just make a copy and give it to the container B. That's basically it. You can have two containers getting added, multiplied, or being in some kind of relationship. Okay, and then you just give the value to the left container. So on the left is the LHS, which is usually, now when I say usually, I mean I'm serious. On the left hand side of the assignment operator, which we call the equal sign, you should always have a container. When I talk about containers, if you've watched the variable video, you know with a container I'm talking about a variable. All right, so on the screen we have 4 of the assignment operator are being used, and so we have A equal 5, B equal 10, C equal A plus B, and D equal A. Now, because we are seeing 5 of the assignment operators, we know we are going to be doing an assignment about 5 times. Four of them, sorry. So A is getting assigned the value 5. That's how we read it. We don't say A equal 5. We say A is getting assigned the value 5, which means get a container in memory called A and put in the value 5 inside it. B is getting assigned the value 10. Get a container in memory called B and put in the value 10. Right? So let's do that one. Now A, which is a container in memory, has been given the value 5, and B has been given the value 10. Now C is saying get a container called C and make sure you find the sum of A and B and store it right inside. So what's the value of A? The value of A is 5. What's the value of B? It's 10. So the two numbers, we add them and we get 15. So that 15, we put it inside C. That's basically what the third line is saying. And because a program will execute statements from top to bottom, we will make sure we are going to do just that. So before we get to this third line, we would have done the first two, right? Now the last one says, whatever is inside A, make a copy of it. Now take note, this one does not delete the item in A. It just makes a copy and gives it to D. So let's take note, right? So D has the value of A. Now what's the value of A? The value of A is 5. And so that settles it. Right, that's just it when we come to the assignment operator. But in programming, we have a lot more operators. We'll find out in due time. This is an illustration. And so just as I use the containers, you can have a variable called your age. That's more friendlier. Your age is 17, which means you assign 17 to your variable age. And then you have another variable, age of your brother. Okay, age of brother. And age of your brother is getting assigned an expression. When I say an expression, you have your age plus 4. So because two items are involved now, we have a variable and an operator with another constant. We are dealing with an expression. And so your age plus 4 now gives us an expression. Because there is an assignment operator, there is always one container on the left. So we do what's on the right, make sure we get a value, and we assign the value to what's on the left. So your age plus 4 is going to be 17 plus 4. So in memory, age of brother is now going to have the result of this expression. Until you are done with what is on the right, you will not assign to what's on the left. So 17 plus 4, we find the answer is what? 21. And so we give the 21 to brother. For an assignment expression, or for an equation, if you want to call it from the maths point of view, we only have one expression. We have only one assignment operator involved. All right. And then now we have age of sister, which is going to be assigned the value or the result of an expression, which is age of brother minus 2. Now, age of brother was calculated to be 21. So in memory, we will have a subtraction. Age of brother, we make a copy of age of brother. Age of brother is 21. So a copy of age of brother will be the 21, and we take 2 from it. We get 19, and we assign the 19 to sister. Take note, this does not change the value of age of brother. We only made a copy of it to do our calculation for age of sister. Let's take note. So now, your age is 17, the age of your brother is 21, and the age of your sister is still, the age of your sister is 19. Even after the age of your sister became 19, the age of your brother still remains 21. All right, let's go. Because we never did a new assignment to change its values. We have different kinds of operators in programming. And the first one is known as the arithmetic operator or the mathematical operator. And the arithmetic operator, it deals with only the math stuff. All right. And then we have the next one, which is known as the logical operators. Okay. We use this more often. Anytime we are having a discussion with someone, we feel the person should make sense. And so we say, yeah, it's not logical, it's logical, illogical, that kind of a thing. That's the operator we use most often. Yeah. But in programming, it may be a little different, but basically it's just logic. You have to make sense, and so that's the logic. Right. Then we have the relational operators. That usually deals with the booleans, or I think the relational operators and then the logical operators do have some kind of relationship. Well, we'll find out when we proceed. So we have the arithmetic operators. That's the first one. And so anytime we are dealing with maths calculations, those are the operators that we use. So we have something like 2 plus 4. The 4 is the arithmetic operator. The maths kind of stuff, the operations we use, they involve the arithmetic operators or the mathematical operators. And so talking about them, here they are. Yeah. We have the multiplication, we have the division, we have the modulo, which is the operator we use to get the remainder after two things have been multiplied together. Or sometimes they were never even multiplied together in the first place. They came together out of some no reason. We don't even know whether they were even together. You'll understand me. An addition and then the subtraction. So let's proceed. How are they used? Before that, let me talk about the modulo. Maybe you'll understand me from here. Hold on. All right, so we said it and then we are back. We said we'll be talking about the modulo operator or modulus. Well, basically, the modulo operator is basically going to give you the remainder. This is not using the assignment operator. This is basically the equal sign, okay? So if you have 7 times 2, you get 14, yeah. Like how we do the maths. Now, if 7 is standing somewhere, and then we use a modulo operator, and then we bring the 2 as a number, we say 7 is standing there, but when 2 goes into 7, what's the remainder? So anytime you see 7 modulus 2, that's what we are looking for. Like that, right? So 7 divided by 2, what's the remainder? That's the meaning, right? And so the remainder is 1. So you can think of 13 divided by 4. 13 divided by 4. 13 divided by 4. 4 goes into 13 3 times. Yeah, making 12, right? And then there is a remainder of 1. So that's the remainder. Okay. Make sure you don't start thinking of decimals because we are dealing with only integers. Okay. Yeah. Or if you want me to do it this way, let me do it this way. Hold on. All right. So I said I'll do it another way. This is the other way. Basically, when we say we are doing a division, we are expecting a split. So how many times will 2 go into 7? 2 go into 7 3 times. That's basically the big number over here. In mathematics, we call it the quotient, okay? But after we have the quotient, which is the 3 over here, what we get next is a remainder. When we proceed, you are going to find out that we are trying to take 2 away from the 7, and so we gave it a color green. So 2 wants to go, okay? So the one who wants to go is the one that's painted green. The one that we get, which is the quotient, the result after the split, is the 3. So just assume 2 and 3 were all inside the 7. They came together and eventually they formed the 7. Think of it that way. But when we try splitting them, because they came together through an operation known as multiplication, they have something to do with each other and then gave birth to some number B called 1. That's basically what happens when we look at the 7. So if you want to take 2 out using the process of division, then we'll end up with 3, which is something that 2 had some kind of affair with to now produce a 7. But during the affair, there was an additional number called 1. We'll understand it in the next slide, and so let's go on. Now, an expression is a combination of operators, constants, and variables. Spoken about that already, like in the previous session. Right. Now, because we are talking about board mass, we don't use... Oh, we are not talking about board mass. In programming, we don't use board mass. we follow a certain procedure, and that procedure is known as the order of precedence. So if we are talking about the order of precedence, we would always want to execute certain expressions first before certain parts of the expression first before we take a look at the other ones. Now, what are those? We have talked about the set of operators in programming. And so we follow a rule, and that rule says we specify an order within which we execute the expression. So the expression will be there, but we'll be breaking some parts of it to execute first before we now take a look at the big picture. Right. Now, when you have an expression, you make sure that you execute the parts of the expression that has the operators in the first order. So I've broken the operators down, 5 operators in the 4 previous slides. I've broken them down into 2, where we have the first order and then we have the second order. Think of the first order as the set of operators that we execute, we more or less evaluate first in an expression. And then the second order refers to the set of operators that we eventually stick with when all the operators in the first order are gone. Now let's take a look at the first order. Think of the multiplication as the operator used for marriage. So when you have 2 items, let's say A and B, and they are supposed to be multiplied together, after the multiplication, we have something like AB. They are bonded to each other, right? Now, that is the marriage. So multiplication is equivalent to marriage. The 2 will come together and become one flesh. I think we have a quotation over there. And now we come to division. Division has to do with breaking that one pair or one flesh that has been brought. So we have 2 items already together. That's the assumption. And so we are trying to split. But with a division, we usually split with one of the partners in the marriage. So B will say, no, I don't want to be in this kind of union anymore. Okay, this one is not a B union. Bond anymore. So I want to split. So always with a division, there is one of the parties in the combination or in the one flesh that wants to go out. But let's think of marriage and then take a look at 2 items coming together. They are already a pair. Nah, they are more or less one flesh. And then they wanting to split. Because of the marriage, they said, be fruitful and multiply. When they multiply, they become fruitful. So they give birth to an extra child. And so after there is the divorce, there is usually a remainder. Okay. So when you divide a number like 7 and you divide 7 by 2, imagine 2 went into a particular marriage with a number called 3. And then during their marriage, they eventually became something like 7. So there was an additional number. Now we are talking about 7. And if you want 2 to split out of that relationship, you are going to have 3 standing alone with the extra child that they got. That's when we are talking about the number 7. Okay. There's more or less a bogus analogy, but I want you to get me. That's why I'm using this. So when you have 7, which is made up of a union between 2 and 3, and they have a child called 1, that's what forms the 7. So the split will always have a remainder of 1. I hope that one is clear. So the product, the operator that will bring out that child, which is the remainder after you divide 7 by 2, which is the 1, is called the modulus operator. All right. So we've talked about the modulus operator already. So the modulus operator is usually what brings out the child after there is a divorce. I've spoken about a divorce, which is the division operator. And then now we talk about the singles. We've spoken about the marriage, which is anything that has to do with the first order. When we get to the second order means that we are done executing or evaluating all statements that has the multiplication, the division, or the modulus in them. And when we are using operators like modulus, multiplication, and then the division, it means we are dealing with the expression that has items related to marriages. All right. The second order has to do with a time when all the products are gone, all the division is gone, and then the modulus is also gone. So we'll be left with items with plus and minus between them. Now we are in the play field, and then so we will see the illustration with a pictorial view. Let's assume we have a variable A, and A stands for a man, and we have another variable B. B stands for a woman. Now on the first count, they decide to get married, and so that is a multiplication. We have A and B coming together, and because they are coming to get multiplied, they become one flesh. And when they become one flesh, well, in mathematics, when you multiply 2 and 3, they don't grow to have children. But basically, they become AB. That's what I want you to understand. Right. Now, in the next set, we have A and B. Because they become AB, AB is basically the whole family. Now, all of a sudden, one of the people inside the product wants to back out. Like, I can't do this anymore. A and B are multiplied together. We are having a divorce. So AB getting divorced, but the divorce is being caused by B. And so when the divorce is caused by B, we have the items. The woman who caused the divorce comes first. Then the man who's also part, okay, just like the division that we did. Okay, the man, and because there was a marriage, there will usually be the children. Okay, so if we remember this slide, we had a whole product in itself, which is the 7. 7 is the number. Now, anytime we are doing a division, let's think of the one at the top as the product. And 2 is already a part of that particular union, okay, the bond. It wants to back out. And so after the back out, there's going to be the man, there's going to be the woman who wants to go, now painted green, and then the children. So that's basically what I have on this side, right? So, yeah. So we have the products. Assume this is the 7, and then the 2 wants to go out. Eventually, you have the number, you have the more or less the quotient, and then you have the children, which is the remainder. After a marriage is broken up, we have the man and the woman, and then we have the children, all scattered. We see all 3 of them live, right? And then we have A and B modulus B. So if there is going to be a divorce, just like what we just saw, then what will be the remainder? Anytime there is a divorce, there is always a remainder. And the remainder is the children. Okay. Now, when 2 people are coming together, that's a man and a woman, and there is the addition. You see, we were told that 2 will come together and form one flesh. That one was the marriage. That's multiplication. So it's not an addition that was spoken of in the Bible. It was a multiplication. So be fruitful and multiply. There was an equation over there. This side, A and B are coming together. This is the dating form. So the man and the woman, and then they are coming together because of the love, and so that's basically the addition. And so when we are splitting them, we split them with something called a breakup. That one is not a divorce. So let's get this concept. I'll use it when we are talking about big expressions. We'll see that in due time. Right. So just like we have this illustration on the left-hand side, we have A being equal to 2, which is a variable having a value 2. And we have B being equal to 3. Let's think of they coming together, a marriage. And the marriage is going to be something like A times B, and that's basically 6. So we know that when we have the number 6, we have A and B more or less multiplied together, right? This one says that AB is a number which was gotten after we multiply A and B. So basically that's 6 over there. Now imagine 3 wants to have a divorce. That means that 3 wants to back out of this whole relationship. But when 3 backs out of this relationship, what will we get? We will get 2, right? But will there be a remainder? Well, no. There's not going to be any remainder. The remainder is 0, okay? So I brought in this for you to know that anytime there's a division, there's always a remainder. But in this case, the remainder is what? 0. Right. Then we have A and B. Now A and B are together and they are saying we are splitting. Yeah, we're married initially. We're called 6. Right now, B, 3. I want to back out. So when I back out, I'm going to produce a value. Yeah. That's more or less the breakup of our relationship, the divorce. But after our divorce, is there going to be any remainder? And the remainder is 0 because we didn't have anything to do with each other. That's basically it. And then we come to A plus B. A plus B is basically A and B coming to stand together. They are just standing side by side. And the value is 5, okay? Because we are dealing with numbers. We are not dealing with the emojis. And then we have A plus B, which is their union. Now, when two people are dating and then they decide to split, it's basically one leaving the whole relationship. So if they were standing together, let's say 3 oranges going to stand with 2 oranges, there was no fruit juice. They were just standing side by side. So if they made 5 oranges and all of a sudden 3 oranges want to leave, it just leaves us 2 oranges. I think that's a little too basic. Yeah. This is where we do the programming, the math side of the programming. If we get this, we will have programming a little bit too easier. Right. Anytime we are giving this expression, the board maths people will say brackets first. Yeah, there is no brackets. Okay, brackets of addition, of multiplication, and division, and subtraction. Or that's not how we say it. Okay, brackets of addition, division, multiplication, addition, and then subtraction. Basically, it doesn't work here. You can try it, may work, but not all the time. So for now, when we are executing expressions, there are rules that we use. And the rule says that we are to start from the left-hand side and make sure that all the marriages are gone from this whole expression. When the marriages are gone, and anything that has to do with division is gone, and anything that has to do with the modulus is gone, then we can have a peaceful resolution of the expression. So let's think of the first expression and take a look at the technique for solving it. Give me a sec. So we have a lot of items over here. These are expressions, a mixture of operators and numbers or variables. Now let's look at how we solve it. So in mathematics, what at all is called a term? When you see an expression like this, first of all, our intention is to make sure we solve the expression moving from left to right, executing the statement using the concept of the order of precedence. So when we move from left to right, we make sure that we execute anything that has to do with marriage, which is be it divorce, be it children, or be it marriage itself. So when we are moving from left to right, the intention is to, first of all, execute anything that is related to marriage. So when we look at it, we see a marriage between 2, something inside 2 getting broken off using the value 3, which is the divorce. So 3 is backing out of this relationship because it means that there is something of 3 inside the 2. You understand the concept that I used? And then this one has to do with there is something inside 2, there is something inside 4, and 2 is backing out of the relationship, but we want to know the children. So when you see modulus, we are basically trying to find out the children out of this marriage inside the 4. And then over here, 2 is standing alone. But when we look in here, we see 3 times 2. 3 times 2 is we are creating a new marriage. So moving from left to right, the items that have marriage in them are this whole thing, the one that my arrow is moving around. This 4 and then 2 has something related to marriage because the operators over there are involved or they are part of the first order operators that I talked about. And then we have this. So the marriage components are this stuff, this one, and this. 2 is standing alone, no marriage or anything at all. So when we start, we will first split them into terms. And when we have an expression and we are supposed to split them into terms, we need to consult mathematics. In mathematics, what at all do we call a term? A term is anything that is separated by either the equal sign or the plus symbol or the subtraction symbol. So when we look at this expression, because we have the plus symbol separating this item and this item, between these two, we have two terms. And then we have the third term here. We have the fourth term. Because there is the equal sign separating whatever is over here and this is also another term. So if you are counting the terms, we have this as one term because there is the equal sign here. This whole thing is what this thing is splitting them into. So we have one term here. This is another term. So we have two terms now. There is a plus sign. So this is the third term. This is the fourth term. The whole bond over here. This is the whole marriage being broken down. So this is the fourth term. And this particular set is also the fifth term. If there was no equal sign over here, there wouldn't have been the x in the first place. It would have been done with the 3 times 2, and then we will have the 2 here as the second term. This will be the fourth term, the whole thing here. This will be the fifth. Okay, this will be the first term, the second term, the third term, and this whole thing will be the fourth term. So that's what I've listed. So this is the first term, this is the second term, this is the third term, this is the fourth term, and the x is the fifth term. We have the set of terms over here because there was a separation because of the plus and then the equal sign. Well, sorry, the equal sign is not painted in red. I wanted to create a particular picture, right? So before you execute any expression of this nature, split them into terms. And when you split them into terms, evaluate the results individually. Now, there is something we need to take note of. Because what we have on screen is only integers, we will make sure that our answer also becomes an integer. So having split this into an integer, having split this into terms, we need to make sure that our breakdown also evaluates to an integer. So let's take a look at how we do it. First of all, you have the number 2. And so when you are dividing 2 by 3, you are supposed to get a quotient, right? The quotient is what we need when we are dealing with division. We don't care about the remainder. For those who know how to convert items into decimal, please hold on with that. Now we have 2 and 3. How many 3's can we get from 2? If the answer is 0, forget about the point. When we are dealing with programming and expressions like this, we don't care about the decimal points. Let's take note. So 2 over 3, 3 in the nursery or the primary school, they'll say 3 cannot go into 2. Yeah, so that's not how we say it. We say the answer is 0 because 3 goes into 2 0 times, right? And there's a remainder of 2. That's basically it. We don't say it's not possible. It can go into 2, yeah, by 0 times. That's how we say it. So the answer for this whole division is 0 because 2 integers are playing, and so we should get an integer. Forget about the decimal. What we are doing here is called integer division. That is programming for you. Now over here, we are not dealing with the decimal, so we don't get a decimal in here. I'll explain that when we move on. We have 4 divided by 2. What is the remainder? That's what this whole expression is. And so 4 getting divided by 2, what's the remainder? When you have 4, how many 2's can you get from there? You get 2 2's. Will there be a remainder? No. But when we have 5 divided by 2, the remainder, that's 5 modulus 2, the answer will say is 1. So for now, after breaking the items into terms, this is what we have. And so the next term is 2. 2 doesn't have any operator with it. Standing alone, and so we don't need to break it down any further. It's just 2. And then we get to the next term. The next term has 3 times 2. 3 times 2, what's the value? 3 times 2 is 6. So we break this thing down, and by breaking it down, we get 6. The equal sign is there, and then the x is there. I want you to get this concept. Let's take a look at the table in the next slide. Okay, so this has nothing to do with what we are doing in the previous slide, but it's just for you to know that anytime an operator is being used in an operation and you have an integer and an integer, you make sure that your answer should be an integer, right? So when an integer over here is operating with any of these operators, meeting an integer, you should get an integer. So if you have 2 times 3, you should make sure you get an integer. And the integer is 6. But when you have something like 7 divided by 2, 7 divided by 2, 7 is an integer. And you are dividing 7 by another integer. Make sure your answer is also an integer. You shouldn't get any decimal. That's the whole point of this table. Make sure that 7 divided by 2 should give you an integer, which means that the decimal part of that division that you were doing in your maths class, you don't bring the decimal part. So if it's going to get you 3.5, in programming, when we are doing this integer division, we don't care about the 0.5. You will find how to get it in due time. But for now, this is the table that governs our rules. When we talk about a decimal or a real number, it's any number that has this floating point in them. Okay. Right, let's come back to this slide. And so we have 2 over 3 and we got a 0 because 3 cannot go into 2. That's what they say. It goes there 0 times. There is a remainder of 2. We don't care about it. The quotient is what we want. 3 goes into 2 0 times, right? So that's it. We've done this, we've done that, and then we are done with the table. So what we do first when we see an expression of this nature is to break them down into this piece, and then we solve them like that. So let's take a look at what we get eventually. Okay, so as we proceed, if we are given such an expression, we need to first break them down into terms. That will be easier for us to solve it. The other way is to move from left to right and then try picking the marriages and solving them, eventually bringing them back to join the singles, and when they join the singles, you solve it. No. I want us to use the easier way, and then so we split them into terms. So first thing is to identify what are the terms in the expression. Now we have a couple of questions over here which we can try out. If you have any questions, you send them to me at the email in the last slide, right? Through the email in the last slide. Or you can drop them in the comment section and others are going to help us. Right. So we come to the question, and so to break them into terms, we first look for the plus and the minus. How many pluses do we have? How many minuses? If we find out what the plus and the minus separates, then we can find the terms. So these are the terms. We have 2 divided by 3 being 1, 4 modulus 2 being 1, 2 in itself standing with no 1 being 1, and then 3 times 2 being one of the terms. And so by having them this way, we just break them down till we know we don't have any of the first order operators involved. So we'll have 2 divided by 3 getting us 0. And then 4 modulus 2 has no remainder. There's 0. And then we have 2 existing by itself. We have 3 times 2, which is 6. So eventually, this is what we have. And then we get 8. So that breaks it down for us. So having the expression looking so jumbly, like in this slide, can easily be solved by using the approach, breaking them into terms and then solving it as expected. All right, so that's it for the arithmetic operation. We go on to the next set of operation, which is called the relational operation or the relational operators. They allow us to compare values, and after comparing values, we find out which one is less than, which one is greater than, which one is less than or equal to, that kind of stuff. And so we use 6 sets of operators, and we have the first one being the equal to operator. We have the next one being the less than sign. We have the greater than, the less than or equals sign. We don't do it like the math one where we have the less than with some bar at the bottom. No. Now we do it this way because on the keyboard we don't have any way to type less than or equal to. Basically, we have the greater than or equal to. We have the not equal to. Yeah, that's a new operator. And then we have another set of operator, another set of the last operator. You understand? The last operator is a symbol used to connect two or more expressions. We'll take a look at the logical and then the relational operators in detail in our next video. But for now, this is going to be the end of our lesson. If you have any questions, forward them to robertdoe@coden.org. That's going to be the email in the next slide. Well, before we go, we are to note the AND operator, the OR operator, and the NOT operator. I'll then treat us to read more about the logical operators. Okay. Oh, here's something about AND gates, OR gates, NOT, that kind of thing. That would help a lot. Now, because we took a look at operators, I have some questions in the next slide for us to take a look at. When you are done solving these questions, make sure you send your answers to the email right after this one, right? So this one has about 6 questions. Solve them together with the ones in the other slide and forward them to me. That will do. Right. So this is the mail that you are to send your questions to robertdoe@coden.org. Till then, we will meet in the next video.